So, artificial intelligence in the energy sector. Is anybody excited about artificial intelligence? It must be the lag about after the lunch break. So, anybody excited about AI here? All right, much better. Well, I don't want to disappoint you, but okay, let's start with a personal story first. I'm sure that some of you will be able to relate. Back in 2000, when I was a student in the electrical and computer engineering department, I had my thesis on neural networks. And back then, using MATLAB, we were trying to estimate the total electrical content of Earth's stratosphere. We're trying to predict how the signals will be deflected, the satellite signals being transmitted in and out of the Earth's atmosphere. Back then, nobody was talking about AI, although neural network machine learning capabilities is the base for artificial intelligence we know today. And nobody could imagine what technology will bring in front of us in 2025. Even those 25 years I've been working for technology automation and energy organizations, mostly dealing with energy efficiency and Industry 4.0 projects, nobody could see where AI could take us, even through the digital twins that were very trendy like 5 or 6 years ago. And I continued diving into what AI could bring into practical solutions. I had the chance through a digital transformation technologies course I was preparing for ESCP Business School, where I've seen how AI technologies could be employed in grid management, supply and demand forecasting, and predictive maintenance. And I thought that, okay, now I know what AI can do, and well, I was wrong. And the thing is that with this kind of technologies, you cannot be sure. I had the chance to meet Anastasios Ulis-Roussis. He is the CEO of SMP-Net, a Greek, London-based autonomous grid management software company. And he explained to me all the intricacies having to deploy a high-end technology into a real infrastructure. I mean, imagine that you have to make so many different calculations, millisecond by millisecond, on energy demand and supply, and at the same time considering weather data, market metrics, and other insights that before it was impossible to happen. And then I said, okay, now I know AI is magic. You can throw anything at it, and it will make everything perfect. But of course, I was wrong again. Because you see, it's not the technology. It's what happens in real life. And as life proved, Spain happened a few weeks ago. Nobody could imagine that the whole country will have no electricity, more or less, for 2 days. Okay? You remember all the chaos that happened. As SMP-Net happens to be providing with their solutions one of the Spanish energy providers, I called up Anastasios and I said, oh, okay, tell me, if they had AI-powered software in every bit of the network, could this thing be avoided? Well, Anastasios was very humble to say no. And he went on explaining that disregarding of the capabilities of the software, it cannot make good for all the inadequacies that we may have in our infrastructure. Which, if you think about it, it makes sense, doesn't it? I mean, AI is an advanced algorithm, and it can be only as good as the systems we are trying to optimize. So, what do we make of it? I mean, is AI good or not? Can we get any value out of it? Or it's just wishful thinking? And in order to have answers to these critical questions, we have the chance to welcome 3 very distinctive individuals, all professionals on AI and the energy sector. So if you will be able to help me welcome Dr. Georgia Koutrika, She's the research manager of AI and data systems on the Athena Research Institute. Thank you very much, welcome. Mr. Maher Chebo, he's managing director in Europe of Universe, an energy AI solutions company. Thank you very much, Maher. He's also leading the digital innovation and clean tech technologies operations. And last but not least, Mr. Mike Jamalukas. Mike is an AI expert, recently departed from the position of general manager from Amazon Web Services, and nowadays he's starting with his own venture, Deep Runner AI. I'm pretty sure you will be up for a very interesting discussion. Ladies and gentlemen, thank you very much for coming in today. And if you don't mind, let's start with our discussion. As we said, it will be 4 rounds. Okay, the first 3 will be one common question, where each one of you will be able to share their insights from their unique perspective. And on the final round, there will be an industry-specific question asked to each one of you based on your experience and expertise, and would like to know what you think about this. Is that all right? Thank you very much. And if we can start with the lady of our company, Georgia. The first topic will be about harnessing AI and generative AI to optimize energy systems and grid resilience. Now, everything shows that we are at a highly transformative moment in time. And regarding the energy sector, AI, and most recently generative AI, promise to revolutionize the resilience of our electric grids. However, we are still operating with energy infrastructure designed for a completely different era. Centralized and predictable electricity generation and distribution. Here's what I would like us to discuss. First, how is AI rewriting the rules of grid architecture and resilience? And more provocatively, given all the hype around AI optimization, are there any uncomfortable truths around the application of AI to the grid's operations that we should also be talking about?
First of all, thank you for inviting me in this panel and for the interesting and very provocative questions. I will start with the first one that talks about the possible positive impact of AI in energy management. And I would like to mention 3 aspects that I see very critical. The first one is actually how AI algorithms can help energy management. Imagine that AI algorithms can operate on large amounts of data, taking into account several different parameters that not even a human can take into account and analyze in real time. And they can make predictions. For example, they can predict whether there will be a failure, how to balance production and consumption patterns. They can help operate the grid much more efficiently. So this is very, very important to have in mind. The second one, and I think you already mentioned that during your opening remarks, and it is something that we see also in other industry sectors, is how AI can help prevent or more precisely predict possible failures of equipment. And that can immediately mean saving of costs and money for the company because they can take care of maintenance before the actual crisis happens. Okay? The third one that I would like to mention is something that concerns me a lot. How, now that we have renewable sources and other sources of energy coming into the energy environment, how do we do grid planning? Okay? And that is, again, an important application where AI can help because it can take into account several different parameters: environmental, context, temporal, historical data about other deployments, okay, and make recommendations. So how do we do this? I would like to mention 2 things here. One is data, okay? AI works well if it is fed with data. And I will use as a common example that we all know ChatGPT. ChatGPT, which is not meant to be used in energy management, for God's sake, but I'm using it as an example that we all know, has been fed with billions of pages and content that is on the web, encyclopedias, and so forth. That is why it can do so well, okay? So something to take into account is that we need to provide the mechanism for data collection, data sharing, and data interoperability. And to that end, Europe, there is this European initiative on a common data space for energy that has already invested over 100 million euros on projects and pilots trying to promote this open data space. I also offer this as food for thought for the next panel. The second thing that I would like to mention, and it is something that you probably already know, and is the Internet of Things devices, sensors, and edge computing. Okay? Edge computing means that instead of bringing everything into a central point, that was more or less what was happening a lot in energy, but also in other sectors. Now with sensors, we can do computations locally, which means we can have more real-time, more efficient, and potentially more secure processing, okay? Now that I hopefully convinced you, and I will not ask who likes AI yet, I will ask it at the end of the panel, so I hope that I will see more hands raising. But there are some not uncomfortable truths, I hope so, but things that we need to take into account no matter where we apply AI. One of these is that, and that it is also very much related to the heart of this conference, energy. So AI is devouring energy, and that needs to be taken into account in order to balance how we use AI and what is the benefit we are getting from AI for having a sustainable future. The second thing that I would like to mention, and thank you for using all the right words in the introduction, magic, I would say AI is God, okay? Nothing like that. AI is our algorithms that we make, okay? And which means that they can do, amazing things, but at the end of the day, behind the scenes, they are computing probabilities of things to happen. Probability for ChatGPT is what would be the next word that I should have in this text, okay? So we have to have this in mind, and the reason I'm saying this is that when we are integrating AI technologies, we need to have also explanation and verification and auditing tools that will help the people that are using AI in the energy sector understand whether what AI is saying, what AI is proposing, is something that they should act upon. So what we say as human in the loop is always imperative to have in energy management, but also in any other sector.
Okay, thank you very much. Mr. Jabot, would be as kind to reply to some questions?
Thank you for the opportunity to be in this panel. The different components for making AI were there for many years. So people had in physics and in mathematics the capacity 20, 30 years ago to do algorithm. Data existed as well. Machines, servers for hosting and so on existed. Now the combination of many things came together to make the AI now so powerful. So big data is possible today. Internet of Things, which means collecting a lot of big data in real time, exists. The power of the machines that are capable to process billions of instructions, the power of the cloud as well, all of that made it very feasible for the AI. Now all sectors are using AI. In the energy sector, it's very simple. We take the whole value chain. In the power generation, now we are capable to do all the predictions of production, improving the cost and asset performance management, APM, managing how much we can produce between central power generation and distributed energy resources, and how we can supply that at any time during the day, depending on the needs. depending on the weather conditions and so on. So this is when it comes to generation. When it comes to the networks, today all the grid distribution and transmission companies are more or less called platform companies. It's all about data both ways, connecting a large number of wind, collecting a large number of smart meters, and collecting all the data and both ways, planning and operating depending on the overall demand on the market. And the last mile to the customers, which are residential customers, like 500 million people in Europe, and commercial industrial customers. This is becoming much more complicated, as complicated as in the telecom, unbundling of the value chain, liberalization of the market in Europe since 1st of July 2007, competition. Customers are not anymore just meters, so we need to define any time and be flexible and changing of tariffs and so on. All of that complexity requires the use of the AI and to predict how we can deliver at the end the energy to these people as close, as cheap, as real time as possible to these customers and as clean as possible to these customers. Okay. Now, the best proof to know if AI is there, is demanded by the market, is to look at some companies in this area. I have no specific interest in, some companies, but I will mention one of them is in the US called Palantir. Well, when I visited them in April last year in the Silicon Valley, they were valued as 52 billion. So today, like 220 billion. Okay. So they are heavily in the AI business, all sectors, energy being one of these sectors. So well, that proves that the market is requesting. They have customers, they have Airbus, they have many customers. And all the companies like SAP, I spent 21 years there. In SAP, where it was like ERP, then moved into analytics, both companies in the area of analytics, business analytics, like business objects, now is heavily investing on the AI. Even the replacement of the chairman of the supervisory board and co-founder of SAP, Hasso Plattner, was replaced by somebody who is a professor, a Finnish professor, expert in the AI. That means something, because the market is requesting that. And I will take the opportunity in the next round to speak about more use cases. Thank you.
You're welcome. Mike, would be as kind to tell us your point of view.
Okay, good.
Great.
Yeah. Hi, everyone, and thank you for the invitation to be part of this panel. In true AI fashion, before I came to this audience that obviously I don't know much about, as in I don't know much about energy. So I had to go to my mini-me, digital twin, my AI clone, and ask Harry's question about what's the best grid architecture and what are some of the things that we should be watching out for. And the AI started explaining to me a lot of things about what the question means and how I should answer it. Starting with, please tell the audience that you don't know what you're talking about, followed by, now tell the audience some of the things that I believe should be relevant and tangible items to answer this question, aka where AI can be really useful in terms of AI architectures as well as resiliency management. So according to my AI, not me, so you can blame hallucinations to somebody else, okay? There are a lot of the things that obviously my peer speakers covered already. There are also a few others that are, in essence, borrowed lessons from other networks and other problem spaces, which are very, very similar in terms of how they operate. So the AI, again, insisted that I talk about network systems and how in the past we have made reliant, robust, and sometimes self-tolerant networks, virtual networks, physical networks, in all sorts of different modalities, and how this can transfer over to grid networks. More specifically, one of the things that I vividly remember that was pointed out is that very often we do end up having catastrophic failures, like the example again in Spain, that was very unpredictable and even to this day untraceable. And what came to my mind is the same things that we have seen in using generative AI these days. For a lot of the boring and repetitive things. And what that is? Automation. In essence, we're taking AI and we are applying it into hundreds, sometimes thousands of test cases. Based on these test cases, we can be, by the way, running these test cases every single hour, every single minute. So you actually have a test bed from which you can look into your grid, you can play all sorts of different scenarios, realistic as well as unrealistic scenarios, and you can simulate with very high fidelity in the same way that we do today for nuclear fusion, different micro events or big events that may lead into catastrophic outcomes. So in essence, coming back to the question about how we can be leveraging AI to find out more about the fractures that may exist, invisible fractures that may exist inside grid architectures today, I think that we have the tools. Now, the tools are as good as the operator. So it's up to you guys, the experts in this room, to be able to come back with actually what does this new grid architecture looks like. But the AI certainly can help us accelerate some of the ways that we find some of these answers, and eventually we create a much more reliable grid networks. Now, the second part of the question, how some of those things may end up not happening. What are some of the things that dogs not barking is actually the language that Amazon often use. So in my opinion, the biggest dog not barking in terms of looking forward is that the technology is moving ahead and is moving ahead at a very, very high acceleration. The question is whether the legislation and many of the other things that need to enable but also unlock the potential that we have created with the technology will be there and will be able to accompany us into this next chapter. So again, with technology, we may be able to be magic, but without legislation, I don't think that any of that will translate into engineering and results.
All right, Mike, thank you very much. So let's move to the second question. We're talking about the AI-driven forecasting for renewable energy integration and demand management. It's a common ground that renewable energy forecasting has dramatically improved with AI, yet we struggle with overcoming the integration challenges and dealing with a completely new reality. As distributed energy resources and prosumers multiply, traditional demand models become irrelevant and in the end obsolete. So here's my two-part question. Is the level of AI sophistication the root of our integration problems? Or have our energy markets and policies simply failed to evolve respectively to our predictive capabilities? And as we face this complexity, what fundamental changes must AI-driven forecasting go through to handle the reality of the distributed energy systems? Maher, would you be able to go first? Thanks.
I don't think there is a failure. Of course, the regulatory was mentioned, and the regulatory should help accelerating the deployment, for example, of renewables. But if I take the example of my business, well, today we have about 780 gigawatts of installed renewables, wind and solar, where we do the monitoring and control and AI analytics, helping reducing the cost of operations and helping reducing the levelized cost of energy to make the renewables more competitive than the central classical power generation. Okay? So here, there is clearly a success, and there is software being deployed everywhere, being used with AI, because all of that was developed on a platform specialized in AI for renewables, AI for energy. Okay. Now, where the failure is before, upfront. So before we come in the operations, you hear a lot of companies that say, my objective is to have plenty of gigawatts. For example, Total Energy by 2030, we will have 100 gigawatts. So they hurry up and so on, but it's a big challenge. So it's taking time. Permits are taking time. Things are slow in the EPC work, engineering, procurement, construction, and this is where Europe needs to improve a lot. In China, things go much faster, and Asia goes much faster, and so on. And once these are in place, then here you start using AI like hell. And this is what we use really heavily. The batteries is another example. Are we failing? No, we are not failing. I heard this morning, batteries. Well, we have concrete project of tens and hundreds of megawatt hour in the UK, in France, in Germany, in Eastern Europe, where investors find there is a good return on investment, where the projects are being deployed, so the procurement, the manufacturing, and the procurement of the batteries, the whole digital and AI, energy management solutions, SCADA, and monitoring and control, long-term service agreement over 25 years, not 5, 25. All these projects are up and running. Harmony Energy, Atlantic Green, Constantine, Calista now, we start project in France. This is working. Again, the challenge is the time it takes for permits for the batteries, the time it takes as well for the EPC to do the work. But once it's in place, AI is fully deployed. Okay? And I can take many examples. I think where we need to accelerate is in the lower scale of renewables and batteries, which means for commercial industrial customers where you need to put with the solar, with the EV charging, with the batteries, we need to standardize that. We need to make it like finger in the nose and deploy that everywhere in all buildings. And that's, for the moment, quite slow, and the profitability is lower than the other examples I mentioned. Thanks.
Thank you, Maher. Mike, would you mind to go on?
Can you? Okay. So I have a little bit of a detour here to this question, which largely goes along the lines of how AI can come to energy as opposed to energy going off and finding AI, aka building technology for technology. So I think that there are quite a few very, very strong use cases that we're seeing in front of us. Some of them are because of the complexity of the distributed energy resources. Some of them are because some of the infrastructure is not moving ahead so fast. Some of them is because the integration that you need to put in place may seem very difficult to do, right? And all of them are true to some extent. Now, I don't think that we have, again, a magic bullet here to solve these problems, but we have the next best thing. I think, as Georgia said earlier, the fact that we have certain probability distributions that can predict the best next, token, as well the next, and so on, gives us superpowers. And very specifically now, if you start moving out what we have seen and what we have used most likely already with AI in plain English or Greek or whatever language you want, and in there, you start putting numbers out of smart sensors, numbers out of batteries, numbers out of anything else that you have in the grid. And now these numbers become the language of energy. And that language of energy fed into your energy specialist model is able to give you superpowers in terms of understanding what is going on in your network, sometimes all the way down to the second or millisecond streaming data, sometimes in a much more batched manner. But at the end of the day, you can actually apply some of these capabilities in place. You don't necessarily need to go all the way back and undo some of the things that you did before in order to predict, in order to improve, in order to optimize. Now you would say, why then would I take this giant leap of faith if I'm already having some of those things and they already somewhat work? Well, it's pretty simple. As I said before, with this capability, you now have a generalized conversation about any topic and any insight that you may desire for a specific use case. So before you know it, you really have a very, very powerful option in your hands that can be applied to your specific business need. And to me, that's where things get interesting and exciting in terms of productivity, in terms of forecasting, in terms of resiliency, and so on. Thank you.
Thanks, Mike. And since you finished with on a positive note, you're going to go first in the next question. So, last topic for today, it's about smart decarbonization, the targeted AI applications to cut emissions and costs. Now let's try to tackle the decarbonization challenge. I think it's fair to say that most organizations still treat decarbonization as a cost center, an expensive necessity rather than a business opportunity. Artificial intelligence at the same time, we're also seeing it having an explosion on AI applications promising emissions reductions. Here's what I'd like you to help us understand. How could AI assist us with flipping the script and identify decarbonization strategies that will actually boost profitability instead of draining it? And number two, which specific interventions do you believe could deliver the most dramatic emissions impact by 2030? Mike, would you mind go first?
I don't, but I think Yoria did not answer the previous question. Is this? Okay, good. Okay. I had no idea.
No, it was not actually. I'm really sorry. Thank you very much, Mike. So, yes, you're absolutely right.
Answer the previous question.
Yes, please. Okay. Please. Would you like me to remind you what it was?
No, I was looking at the time, so I thought that it was part of the script, 3-2 combinations to make it more interesting for the audience. No. Okay. But it is good because I want to take the opportunity to answer to three things that I heard. Your question, the superpowers, and something about AI that you mentioned. Okay, so I will start with superpowers, which I liked it, and I would like to use an example because with examples we can understand things more easily. So AI has been already integrated into medicine in many different ways. And I would like to mention one example that for me is breathtaking. Drug discovery usually takes something along 10 years, okay? Because the scientists need to go to the lab, test many different compounds until they reach the ones that should be put into tests with users and so forth, okay? Now, with AI, what we can do, and it is done, is to test millions of different compound combinations and, reject them before they reach the labs. And that cuts down the time to drug discovery and the costs amazingly. And if you don't believe that, we have already experienced the result of this happy marriage between AI and medicine during COVID, okay? Why these drugs came out so fast. Now, I will go to your question. Since you are the moderator, we need to answer your questions, which is very, very critical, I think. So, is AI responsible for, the failure somehow of integrating AI into energy? So the easy answer is no. I think that what was happening until now is much different from what is happening now, okay? So in energy, and I'm not an energy expert, for God's sake, but I do understand data analytics. I've been working on that for many, many years. What happened so far was that in energy management, they were using kind of simple statistical tools. They could make, for example, similar day comparisons. They were operating on a grid that was quite stable, okay? That has changed. Again, the entrance of renewable sources, of new energy sources, has changed the equation, because now we are talking about unpredictability, we are talking about instability. How can we have the same tools operate under totally different circumstances, okay? And AI has already shown that it can help, for example, try to predict offshore wind, which is, I mean, who knows when the wind is going to blow, okay? So that is one thing. And on the other hand, what I would like to mention, kind of trying to link it with what you said earlier, that AI is not, you just don't take an algorithm and it will work perfectly between two different things, okay? And we are trying AI on energy data. Different models will produce different results. With different data, they will produce even more different results. So we need to experiment and we need to customize before completely adapting them. I don't want to eat any more of the time. I sit here 4 minutes.
Thank you very much. I'm very lucky to have a very polite guest today. So Mike, back to you. Just reminding the questions, how could AI assist us with identifying the decarbonization strategies that will actually boost profitability? And number two, can you see any specific interventions that could deliver the most dramatic emissions impact by 2030? Thanks.
Yeah. So I'll try to make it really short since we are, running over. So I think just like in many other problem spaces, AI has a lot of let's say, good fit in problems that have to do with combining a number of different inputs into an insight. So for me, that is really the decarbonization equation statement. So in essence, what does it mean for you to be able to measure and to improve your carbon footprint? It means that you have a way of assessing what that looks like, measuring it, and being able to optimize it. So coming back now to the second part of the question very quickly, if I play that forward, I can see how AI agents, think of them as glorified AI assistants, integrated with your business, which, like I said before, it doesn't have to be an open heart surgery. It can be something that can be applied within your daily operations and can be integrated and can be executed. So the way that you actually mirror some of your operations will be reflected in this agent as the different inputs, day to day, hour to hour, whatever that means. And that agent now can help in some ways find out the insights and the ways that companies can improve. I know that one big company, not to be named, is already investing in some of those agents. And yes, every single package that you get from that unnamed company, hint, is now having an agent that tells us how much carbon emissions did we spend for that, all the way down from a distribution center to your doorstep.
Very much. Georgia, would you mind to go next? That was the right order.
Okay, now I have the privilege to talk again. Okay, so it is a tricky question, actually. It was the hardest for me to answer because I understand that companies do not see the benefit of using AI, and they are reluctant or suspicious on one hand, but at the same time, they're all very eager to ride the wave of AI because, this is a fancy word, AI. We should do it, right? So there is there is danger, if you like, at both sides of this equation, and I would like to to emphasize that for a moment. Now, being a data person, I would like also to share the fact that most companies produce a lot of data for their operations, for the buildings they have, for the people they have, lots of data. Do you really know how much of this data is actually ever used for anything? Just 20%, okay? And, that says something, because data, we say data is oil. I was in a panel between Europe and Asia last week, and there was a person saying there, a professor, that we have gone through steam economy and electricity economy. Now we are in the data economy and the AI economy. Okay, so this is something that we need to work on and try to do our best to be on the right side of the wave. Going back to how this will help us, a very simple example that many companies have actually done this, building energy management. So collecting data from the air conditioning, from the heat systems, they can make better decisions, automated decisions on how to distribute energy, how to use it, when to use it, which is much more efficient and also, cost efficient from saying, oh, you have to keep the temperature in this room 19 degrees Celsius, not higher than that, not lower than that. I mean, okay, this is just a rule of thumb, doesn't say anything. So I think there is a great opportunity on that, but also we need to, to take it very carefully.
Okay. Maher, would you mind to share your point of view?
Yeah, I will try to be short as well. Just three key words as a takeaway from my side. One is the onboarding. We will be successful with the whole energy transition and accelerated transition with the deployment of renewables and so on if we have developed all the AI-based tools for onboarding all the solar and wind and all the assets on the software platform for that, which is based on AI. This is one. Second is the integration. So we cannot calculate the carbon footprint, scope 3, in a silo. So we have to integrate with the ERP systems. ERP systems have all the information about the vendors. All these vendors contribute to the calculation of the scope 3 of carbon. So that integration is important. And third thing is having the holistic view. What's the overall performance of a power plant? What's the overall performance of a fleet of wind turbines, of a fleet of solar, and so on? I have one example which 10 years ago I have posted about it when the first war Crimea happened between Russia and Ukraine, which I called it in my post on LinkedIn, the energy cockpit of Europe. It's like a cockpit on the plane, collecting all the data about how much Europe is producing from all sources of energy, how much the need is and the predictions of the need, how much we are importing from outside. That time, the energy independence was about 57% in Europe. And of course, if one day you say, okay, let me cut the import of gas from Russia, well, there is no tool, no automated tool, except just making a conference, European Commission asking for people to come to present PowerPoints, that could react automatically to that to predict how we can still have and improve the energy independence. So today, a fantastic example, holistic example, which is very intensive AI and so on, would be the development of an energy cockpit for Europe that could anytime react and predict how could be the best energy system supplied to the customers that could, at any time where we have an event, a war, and so on, we cut gas, for example, imported from here, react and say, okay, this is the solution. This is what you have to do in France. This is what you have to do in Greece. This is what we have to do in the EU 27. Thanks.
Thank you very much for this pragmatic approach. Now we're going to the final round of questions. I'd like you to make the answers just a couple of minutes, a little bit shorter, because I ran out of time. Sorry about that. Now we're going to ask some interspecific questions based on the expertise of each one of our guests, starting with your year. Quite often, academic research operates at different timescales than one industry's needs. How can we bridge the gap between cutting-edge AI research in energy systems and what are the practical requirements of energy operators who need solutions that work reliably today?
So I have to let you know that he gave us two options, and I immediately chose this one because it was the most provocative one, and I feel that I can answer it because I have spent almost more than half of my professional life in industry, and I also have an academic profile, so I understand that I want solutions now, but I also understand that there is a gap on how you reach that. To keep it short, I would like to say that the way to build this is to build bridges between the different communities, the different skills. So, like what we're doing here today, but for example, maybe with more people from technology and AI parts, where we can sit down and discuss, what are the problems, what we need to do, and so forth. So that is one idea. Coincidentally, this week, another conference is happening, interdisciplinary conference on AI and astrophysics. And because, AI and astrophysics can work together so nicely. But what we found out, the two different communities, was that we as AI people, as technologies people, we were trying to imagine what problems they have and solve them and also find the data. And they had the problems, but they didn't have the solutions, and they were trying just to get, AI tools and use them without understanding what they are doing. I think we can do better than that if we just find the ways to communicate with each other. And again, I'm preparing at least the ground for the next panel. There are, for example, European projects where companies and academics can work together. So this is another way to think about it.
Thank you very much. Maher, would you mind being next? Now, at the company you are leading at the moment, Universe, you are using AI to help with decarbonization. So could you mention some AI use cases in the energy sector, and what outcomes can they provide?
Yeah. So I will start by the simple one. Well, this building, I'm sure it's not optimized. So if we collect the data at a certain granularity, and that we start by onboarding all the data and by putting IoT technology. So we have small boxes like internet boxes. We get them manufactured according to our needs. And these boxes are magic because we put them everywhere here. We connect them to the meters, smart meters, to the different equipments. They take all the data from the physical assets, put it on the cloud and the software. And once you have the data, it's fantastic. With all the AI you have, you can analyze it and you say, okay, this is consuming more than it should be, right? And you do it continuously, not one time. It's continuous monitoring and control for the buildings who are allowed to control, for example. Then we could act, turn off, lower a bit, and so on. And you do that 365 days a year, for sure, you will optimize. 5%, 10%. I was working recently on a tower of one of the big banks in France, in La Défense. They have a bill of 2 million euros. So you do 10% savings. Well, this is a lot of money. Energy efficiency and carbon management, all of that calculated, and you can imagine how many buildings you have in the world. So this is one. Second is, when you have complex factories, complex buildings with solar, EV charging, batteries, all of that area for optimizing that's called AI microgrid and flexibility management. Okay. In Netherlands, you pay penalties if you consume more than the subscription that you have. Okay? So then we help a big retail chain called Albert Heijn to reduce their energy and not exceed the subscription. Big use case. Third thing is overall fleet management of batteries and fleet management of renewables, that we could optimize the production of renewables, the operations, predict the incidents and everything over a large number of distributed energy. In terms of numbers, we have 200 million IoT assets connected in the area of buildings. We have 40 gigawatt hour of batteries for which we do monitoring and control and AI analytics, long-term service agreements for 25 years. We have 780 gigawatt of renewable assets for which we do monitoring and control and AI analytics. This is concrete. It's not academic. It's reality.
Thank you very much. And Mike, now come back to you. As General Manager at Amazon Web Services, you work closely with data center infrastructure that consumes significant amounts of energy. What did you learn during that time, and how does this relate to what you're doing next with Deep Runner AI?
Yeah, obviously a self-fulfilled prophecy question here, because that's what I've been and that's where I'm heading. But taking the opportunity to speak a little bit about what's near and dear to my heart. As you may have heard, there is a race. And what is that race? It's basically more and more GPU-enabled data centers. And that means more and more energy and more power that is needed, to the extent that you could see all kinds of different renewable energy sources and sometimes creative ways of going out and finding that kind of energy. In addition to that, there is obviously a lot of work in being able to optimize some of the systems that use that energy to power all these AI queries, all these AI search prompts, if you wish. And behind it, there are multiple layers, in essence, of the onion that you need to look into in order to be able to do a better job. That's a little bit of the before. And like I said, tons and tons of things that are invisible to someone using AI, but visible to someone building a data center and everything inside the data center like AWS. Now, looking forward, I think that there is an opportunity in the intersection of different business verticals with applied AI. And this really has a lot to do with segments like energy, where we see very, very specific needs, both on the grid side, as well as on the demand and supply balancing, as well as on all sorts of different forecasting, resiliency, and other good things that we talked about. So we, now at Deep Runner, are going to be able to help you in the journey of integrating and accelerating the use cases that you have in front of you. Whether those are some of the most boring and the most repetitive tasks, like let me check a dashboard that says that something is going towards the wrong direction. And you may do that once, you may do that 10 times a day or what have you. Or whether this is a much more complicated type of analysis where you would like actually something else to go off and run an experiment, run a simulation, run a load test, come back with some results, and figure out whether there may be, in the future, a higher risk of some sort of bottleneck or outage or even price deviation, right? So a lot of these exact kind of like use cases will be things that we're going to be looking at. And we look forward to learning more from some of the leaders in the space, and we're looking forward to be able to help them.
Thank you very much. And with what Mike said, we're just finishing with today's conversation. Hopefully you got a little bit wiser on how AI stands at the moment and how it can help us go forward. Georgia, Maher, and Mike, it was a privilege leading this discussion. Thank you very much for all your beautiful insights. And hopefully we'll be able to continue this discussion sometime soon. Thank you very much.